In the last section of Unit 6 from our Statistics OER course, we will discuss the distribution of the sample proportion. This distribution is in the Openstax and Lumen textbooks in the next chapter. So this is the introduction to the population proportion at 8.3 in the Openstax Introductory Statistics textbook, and in the Lumen textbook is in Module 8, the introduction to a population proportion, and it is the first preview of how we go about calculating or estimating proportion from a sample proportion. Now, the reason we want to do it here, though, is because we have introduced the distribution of the sample mean, and oftentimes, we will have the distribution of a sample proportion. And we have already seen that the normal distribution in the previous chapter has been used to estimate binomial distribution. So, in a proportion scenario, the underlying distribution is a binomial distribution, and we will not be using the mean or the average of the sample. We will just be calculating the proportion of the observational units in the sample that satisfy a question, a condition, and then the rest of them will be considered the failure. So if X is your binomial random variable that follows a binomial distribution with n repetitions and probability of success P, and n will be the number of trials and P the probability of success, to form a proportion, we divide X, the number of successes, by n, which is the number of trials or the sample size. So we use the notation P prime. Our book uses the notation P prime, and that will be the quotient X divided by n, X being the number of successes and n being the sample size, the number of times you will repeat the question. And also another notation, most popular, is P hat, so P with a little caret at the top. And P hat again will be X divided by n. The P prime or the P hat indicate the calculated proportion as an estimate of the population proportion. And when n is large, greater than or equal to 30, and P is not close to 0 or 1, so that n times P is greater than or equal to 10, and n times Q is greater than or equal to 10, then we can use the normal distribution to approximate the binomial distribution. And if you remember, the variable that X that is now a numerical variable will follow a normal distribution with mean n times P and standard deviation the square root of n times P times Q. And this was part of our mean and standard deviation of a binomial from the midterm, from the first half of the class. And therefore, when I divide by n to calculate the proportion, X divided by n or P hat, all of these values will be divided by n, and we will have a mean of P, which is the population proportion, and a standard deviation of the square root, P times Q divided by n. So, P hat again, we will find it as the quotient of the number of successes in the sample divided by the sample size. P hat will be the estimated proportion of success, and the z-score formula will be your P hat or P prime minus the mean, which is the probability, the proportion in the population, divided by the standard deviation. And there are two notations for P hat, the P hat or the P prime, and there are also two notations for the population proportion, the P or pi, or the Greek letter pi. The standard error for the proportion is the square root of PQ divided by N. So knowing this, let's try to solve a couple of problems. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. So the population is the adults living in a large city, and the variable that we care for is whether they have a cell phone or not, which takes two values. Yes, they do have a cell phone, and no, they do not have a cell phone. Let's write that down. So we have the population the adults in the large city, and the variable whether they have a cell phone or not, which is a categorical variable, and it takes two values, yes or no. Yes will be a success and no will be a failure. 500 randomly selected adult residents in the city are surveyed to determine whether they have cell phones. So the N is the sample size of 500, and of those surveyed, 421 responded yes. So X was the 421, and from here you have P hat equals 421 divided by 500, which is equal to 0.842. And from here you can find the Q hat, or 1 minus P hat, to be 0.158. The rest of them. Use the empirical rule to find the estimated interval of likely values for the proportion of adult residents of this city who have cell phones. So the empirical rule, if you remember, pertains to the normal distribution. So we want to discuss if we can use the normal distribution. And the answer is yes, we can. N is 500, which is large enough. N times P is 421, which is greater than 10. And N times Q is 79, which is also greater than 10. So the answer is yes, we can use the normal distribution. Once we can use the normal distribution, we want to remember what is the mean and what is the standard deviation of this normal distribution. So your P hat follows a normal distribution, and the formula that is available in our course under final exam, final formula page, has the distribution of the sample proportion to be normal with mean P and standard deviation square root of PQ divided by N. So the mean will be P, and we will assume that it is 0.842 because that's our estimation of the population proportion. And then for the standard deviation of P hat, we want the square root of P times Q divided by N. So this value is the square root of 0.842 times 0.158 and divide by 500, which is approximately equal to 0.0163. So P hat is 84.2% and the standard deviation is 1.63% approximately. So we want to to sketch the normal distribution. If you remember, the normal distribution has the mean in the middle, 0.842, and tick marks to the right and to the left. each one equal to a standard deviation. And this is the proportion of adults living in the large city who have a cell phone. There are no units for proportions. The percentages do not have units. So pause the video and fill out the table to make sure that you have the correct values in the bottom on the axis. So if you remember, the empirical rule says that 95% of the data is within 2 standard deviations from the mean. So 2 tick marks to the left and 2 tick marks to the right. The middle 95% are the interval of likely values of this variable, which is the proportion of adults, the estimated proportion of adults in the city who have a cell phone, so that will be 95%, and this is the interval of likely values. So we think that the proportion of adults will be from 80.94% to 87.46%. The next question says, in the above scenario, find a proportion value that has a z-score equal to negative 1.96. So if you remember, x equals the mean plus the z-score times sigma. This formula was in our midterm formula sheet as just the calculation of the z-score, so this you have to solve it for x, but also in the final formula sheet is called the standardized score, and it looks very similar. It just uses words because in this chapter, in the second half of the course, sometimes we will have population and sometimes we will have a sample. So if we solve for x, x equals the mean plus z times sigma. The mean in this example is equal to 0.842 plus the z-score is negative 1.96 and the standard deviation was approximately 0.0163, and when I do this math the answer comes out to be 0.810052. So this is approximately 81.01%. That's the proportion. This concludes Unit 6, which had to do with the central limit theorem, and in addition to checking the distribution of the sample means and the distribution of the sums in a sample, we also checked in this last section the distribution of the sample proportion.